Now let's finish up our lesson on Gestalt. And again, the Gestalt laws are the robust rules that describe the way that we see patterns in visual displays. And it's the German word for pattern. So it's that second symbol mapping principle we're talking about. We have marks in the medium, we have these marks in the world, and how are people interpreting those marks and making sense of them so that they're not seeing the marks anymore, they're not seeing the dots or the blobs or the pixels, they're seeing representations of the world. So now we'll finish out with continuity, closure, and figuring ground, and how figuring ground changes with the size and number of the objects and the area relative to the total size of the display. So the area of each of those different objects with relative to the total display size. So let's get right into continuity. Let's do this a little differently than we've done some of the other ones. Let's get right to our thought exercise or our drawing exercise. So again, if you could get out a sheet of paper and a pencil, and this represents two objects, and I want you to draw them for me. Yeah, you can pause the video. So how many of you drew it as B, and how many of you drew it as C? So raise your hands if it's B. Just kidding, I know that you wouldn't be able to see it, or I wouldn't be able to see it if you did it. But I want you to think through, or at least you'll be honest with yourself, if you didn't draw it, which one were you thinking about? Were you thinking about B, or were you thinking about C? And which way you chose, and most people do B, they don't do C, although either are possible, because this law of continuity is again so powerful. So we see this curving form and it's continuous all the way through here, and we think that must be the form. This must be the signal. This is the background behind it, and so when it pops out, it's going to look like this. But this thing where I would say no, what's really happening is going here. It's going to take a left turn here, and it's going to take a left turn there. That's not likely. It doesn't happen in the world very often that way, so we don't see it that way when we draw it. So if we apply that to some of our visual displays, what you're looking at are a series of two very messy network diagrams. Those continuous versus angular connectors should be easier to see what's connected to what. And so visually I want you to do that. So take, for example, this dot right here, and tell me, visually, can you go up and look to see where it's connected up there? Then take this one right here, and visually go down and look to see where that one's connected to, or what are all the ones that it's connected to. Now try to do the same thing over here, and just try to do it visually. So some of those are pretty easy. Even on the right, you can basically see that this one is connected to this one, but after that you kind of need some help. Maybe you get this one visually, but like tracking all the way through up to this one, that's a lot more difficult. But on the left, if you do the same thing, you say, okay, it's this one, and it's this one, and it's this one, and it's this one. That's a lot more straightforward. In fact, I think I may have even made a mistake over here. Yeah, I did. It's not this one, it's this one down here. So this one, I should have connected it to this guy right here. Easy enough mistake to make if I'm doing it over here with the angular ones. Okay, you guys know the drill by now. Take these two figures that have been drawn together, take them apart, and tell me what the figures are. Again, I'll wait. Again, it'll help you a lot if you actually draw this one out for yourself. So again, show of hands, who did this one? So I'm assuming, and you guys get to see my amazing online drawing talents here, I'm assuming you drew something a lot more like this. Yeah, I got the wrong colors, but hopefully you can kind of put that together. And then this kind of over here, right? That's probably closer to what you guys drew. It may have never occurred to you that maybe we weren't overlapping here. It actually was just this shape and that shape. So now let's combine continuity and closure and start to say, okay, so what are these things? So I have a bunch of these different lines, or actually I have a bunch of different lines that are connected with a bunch of other different lines. Where are my shapes? How do the shapes kind of come through? And this one is, you could do it a couple different ways, but there's one way that most people will do it. And that way is here A, and then B, and then C, and then D. Now, sometimes continuity and closure isn't enough, so we need to do something else. So you can use something like similarity to start making that a little bit easier on yourself. So this one could be a mess if I'm just using lines of the same line width. So now we're seeing all kinds of different similarity things, whether that be texture over here different than the texture over here, or even though these two forms are not filled in, they have different line widths and different line colors. These have different background colors. You have transparency in here so that I can kind of see this even though it overlaps. All of those coming together help me make sense of those forms and make it clear which ones are together and which ones are not, even though the sides of them overlap and intersect. Closure, again, is very powerful in helping me understand what are groups and what are not groups, and we can see that pretty clearly when we take them away. So if I took these away, it's a lot more ambiguous about what goes with what. It's not terrible because I still have proximity, but what if instead now I close them with something else? Instead I close them in boxes like this. Again, that's it's strongly showing group. And the last one we'll talk about here is figure and ground. And with this one, lots of what figure and ground is in the real world has to do with our expectations and interests of the observer, which we'll get into as we go forward. We're just talking about the marks in the medium right now. So with this one, do you see a white fan or do you see a black fan? And now that I've said it, if you saw the first one, can you now see the other one? It's very ambiguous with this one. Which one is figure and which one is ground? Which one is the thing I'm supposed to be paying attention to and which one is just an after effect or a shadow? Same thing with this one. What do you guys see pictured here? So can you see the vase that's right here? Okay. Can you see the two faces that are here? Again, which is the figure, which is the object, and which is the background? Again, unclear. So we're with both this one and the last one with the fan, both figure and ground take up relatively the same proportion of the visual space, so it's very difficult to see. And this idea of figure and ground, it's kind of using a lot of those other Gestalt laws. What do you see here? Do you see what is pictured here? So who of you see a white object here that just happens to not have any outline? So are you subtly filling in all of these spaces here? Or conversely, do you not see that at all? You just see a series of these very odd shapes. A series of squares and rectangles with something bitten out of them. Do you see, with this here, do you see one line that's cut in the middle, or do you see one line here that's cut in the middle, or do you see two lines? The continuity principle is really strong in helping us to understand figure and ground here. So what I wanted to show here is how noise, in this case visual noise, can severely restrict or inhibit our ability to see figure from ground. So what you're looking at here is actually my desktop screen once upon a time, and it's actually, if you look back here, it's actually while I was creating these slides. So if you look back here, these are the slides you were just looking at. And so I wanted to take a screenshot of a website. It's actually, the website is lingscars.com, by far the noisiest website I've ever seen, and this isn't even moving yet. So I wanted to show my students how this thing, how noisy it is when it moves. And so when I went to take the screen recording, I couldn't figure out how to do it. I said, hit screen recording, and it never started. It never started. And I was trying to find the button. Where's the button? So you guys can play Where's Waldo for a little bit, and if you want to, again, you can pause it if you want. I'll give you a couple seconds. Where's the button to start this recording? And I finally realized it's right here. And like, that's the worst software in the world. How would I ever find that? And then I realized if there wasn't all this noise around it, I could find this figure quite well. But everything started to look like ground. Everything started to look like background. Everything started to look like noise. So now let's put all of those Gestalt laws together so we can start to see how we see things. How are we going to make these into patterns? So what you're seeing here is a pencil drawing of Manhattan. And I want you to first look at the marks. There are an innumerable number of lines and dots and little blobs of color here and there, and more lines, and really lots and lots and lots and lots of lines. And with all that said, it's very clear that I'm not looking at lines, I'm looking at buildings, or I'm looking at flags, or I'm looking at city blocks. And I'm not just looking at them in 2D, I'm looking at them in a 3D projection, and a very specific 3D projection at that, one that allows me to see the height of these buildings with respect to each other, even though it's not a direct comparison in a 2D frame. So again, as we go back to that idea about what is data overload is not the number of marks in the medium, it's the amount of information that I can gather from those marks. When done inexpertly, those number of marks start to be correlated with data overload. When done expertly, those number of marks can actually reduce the data overload.